Nearly all suspension systems use springs as a basic component. Springs support the weight of the vehicle, maintain correct ride height, and absorb shock. Vehicle design and available space dictate the location of springs in the suspension system. There are various types of springs: lighter springs for passenger cars, heavier springs for trucks. We'll discuss coil, leaf, torsion bar, and air springs. When weight is applied to a vehicle, coil springs compress. Because the coils have a natural tendency to resist compression, they dissipate energy by trying to return to their uncompressed state. Springs are rated by the amount of force required to compress them 1 inch, usually expressed in pounds per square inch, or PSI. Two terms are used to describe spring movement. Jounce occurs when a wheel hits a bump and moves up. Rebound occurs when a wheel hits a hole in the road and moves downward. Coil springs are typically mounted between the lower control arm and chassis and permit the control arms and wheels to move up and down. The upper control arm is often shorter than the lower one, pulling the top of the tire inward during upward suspension travel. This increases tire life by reducing tire scrubbing, often associated with making and breaking road contact. Coil springs may use fixed or variable rate designs. In a variable rate design, one end of the spring is either wrapped more tightly, made from different gauge steel, or has a different number of windings than the other. The variable rate design enables coil springs to handle both light and heavy duty loads without sacrificing ride quality. A variable rate spring can have a combination of coil wire size and unequal spacing. The spring rate varies. A fixed rate spring has one size coil wire and one basic shape with even spacing. A fixed rate spring has a constant spring rate. Coil springs eventually sag because of age and deterioration. A sagging spring will affect vehicle ride height, wheel alignment angles, steering angles, braking, tire wear, and wear of other suspension components. Spring maintenance is normally a replacement effort. Check for a tag or part number stamped on the old spring. Examine the spring to determine the type of end it has: full wire open, tapered wire closed, or pigtail. Check your catalog closely to ensure the replacement is the correct spring for the intended use. Caution: anytime service is performed, the spring tension must be unloaded. Use a coil spring compressor to release the tension. Leaf springs connect the axle to the chassis and are found on light trucks, SUVs, vans, and a few passenger cars. They have a good load carrying ability. A monoleaf spring is a thick arched strip of steel or other composite that tapers off at each end. A multi-leaf spring has multiple layers of spring steel stacked together in the shape of an arch. Generally, one main leaf is attached to the chassis in shackles using spring eyes. Progressively shorter leaves supporting the main leaf are held together by a rebound clip at the ends and a centering pin in the middle. Material may also be added between the leaves to reduce friction and noise. When weight is applied to the vehicle, the springs compress. The shackles allow the arched leaves to flatten during their stroke. Because the leaves have a natural tendency to resist flattening, they support the vehicle's weight by trying to return to their original position. Caution: anytime service is performed, the spring tension must be unloaded. Raise the vehicle so the drive axle is suspended. Some leaf springs provide two-stage resistance with a lighter first stage spring providing a comfortable ride and more rigid second stage springs increasing weight carrying ability. Leaf springs are strong, enabling them to control body sway and resist lateral movement. Torsion bars are spring steel shafts that are usually attached to the vehicle chassis and the lower control arms. They are lightweight, compact, and provide greater resistance than equally stressed coil springs. They can also be used to adjust ride height. When motion from varying road surfaces is transmitted to the control arms, they move up and down, twisting the torsion bars. Because the torsion bars have a natural tendency to resist the twisting motion, they react to the motion by trying to return the control arms to their resting position. Caution: anytime service is performed, the spring tension must be unloaded. Air springs are an alternate type of spring that can be used in place of coil springs. The air spring is a rubber cylinder filled with compressed air.